So Sarah and I definitely did not coordinate our talks, but I feel like you totally, completely set me up for my talk for a couple of reasons. One, I figured in this room there were a bunch of different case studies that I didn't even have to bother introducing just because they're pretty well known now and people in this room would already know. A lot of the ones that personally have influenced me, in addition to the ones Sarah mentioned, were some of the Kate Crawford and Julia Angwin work around both recidivism rates and AI being used to be better decision makers than humans, as well as the work around Amazon Prime deciding that wasn't going to deliver to certain neighborhoods, which happened to be the same neighborhoods that were red line neighborhoods because of their algorithms, and then also like Joy's work over at the MIT Media Lab around facial recognition software that none of them recognized certain skin tones and certain facial structures. So I want to preface that by a lot of that work really influences my own work as well, and you jumped into that. And also, I'm a technologist, so as you pointed that out, these are my people. And so I want to give you a little bit of background about myself because it informs this work. I'm currently, as David mentioned, I'm teaching a class at Harvard called Product Management Societies, so how do you build software in public sector and government settings. And we go through the product management stuff like metrics and sprints, et cetera, but in every class we weave in things like inequality and ways of like unintended consequences and how you have to consider that as you build anything. And I also run, with a similar name, the Ethical Tech Working Group at the Harvard Berkman Klein Center, and worked with the MIT Media Lab on the Ethics and Governance of AI initiative. But what has been so deeply important to me is working with people like incredibly passionate people like Yoav over at the Midyar Network and the Mozilla Foundation to recently launch the Responsible Computer Science Challenge. And what that is this that idea of recognizing there's a lot of work going on with regulation, there's a lot of work going on changing industry culture, there's a lot of work going on across academia, but we have to get to the core of computer science curriculum and computer scientists. The people who are training the next software engineers, the next product managers, but the folks that kind of still have our earmuffs on a little bit when it comes to this topic. So many of us go into technology because we want to empower people. If you're walking to any computer science department, how many developers do we have in the room? If you walk to any computer science, or anyone who's learning how to code, you do it because you want to build cool stuff to really help people. And somewhere along the way, that last point in one of your slides, you have all these unintended consequences. You're like, oops, I don't know what happened. But you get into it because you really want to empower people, and you want to tell, and so I got into it. This is Pascal. It's this totally obscure language. It's the first language I learned. And I remember writing this program that can print out a receipt, and I can change anything on that receipt and think to myself, oh my God, I can tell a computer what to do. And I just had my students read a chapter from this book called The Mythical Man Month. It's a very, like a software engineering centric book, but there's a couple of chapters that really just talk about how engineers go into this world because we want to build things, we want to help people, and we want to figure out how things work. Nowhere does like unintended consequences or ethics or any of that thinking really play into that. So I spent about a decade in private sector at Google and IBM. I spent 3 years building out something called the United States Digital Service at the White House under President Obama, and thought so much more deeply about this idea of focusing deeply on humans as we build technology, public interest technology, and what that means. So the idea of like public sector, government, what happens when government technologies fail, and then tying that back to things like Cambridge Analytica and then private sector, because for me it's all like the same bucket of stuff. And so I started thinking more like what got us here, and this goes to Sarah's point a little bit as well. When I studied computer science, there was definitely a hierarchy of major at my university. There's like the engineering and tech folks are kind of up here, whether it's because they end up getting paid the most or whatever. There's this unspoken hierarchy of majors. It's not fair, it's not okay, but there is. And then as you go into tech, places like Google label people as eng and non-eng. People at Microsoft sometimes are labeled as software engineering, which is SWE, versus support. And what that translates into is the engineering teams make a lot of the decisions, and the UX folks, or the social scientists, or the philosophers, other people you hire on, or the policy folks kind of sit on the peripheral, and that informs how products tend to get built. And that's problematic because we end up getting products that we have today, where all these other deeply human disciplines are kind of on the peripheral. Again, it's not the only method of how companies operate, but it's definitely an observation that I see where we don't honor other majors and other disciplines, and we end up with engineering being quite siloed. And siloed engineers who think we're actually building the right things for the world, and we don't consider the unintended consequences. So I wanted to throw up these 2 slides. These are just 2 examples of the many computer science curriculum right now that currently exist. I won't name them, but you can easily find out who they are. So at one of the universities, you pick a particular thread when you study computer science. You can decide you want to really focus on media, system architecture, theory, or a whole entire separate section is people. You can decide that you can specialize in design, build, and evaluate systems that treat humans at the central component. This is a totally separate discipline. This is crazy. This should be completely pervasive across the entire curriculum, and similarly here, you have the core curriculum here, and this university is thinking about ways to integrate humans across, but for the most part, this is how we're currently teaching computer science programs. Again, not by lack of people, by people who intentionally want to do harm for the world. This is just how we've structured how we teach our engineers. One of these is the university I went to. Ethics classes are not new. Again, Sarah set me up for this. This is Casey's crowdsourced list. If you haven't met Casey Fieser, she's an incredible person who has a background in psychology and law and computer science, and is now thinking about how to teach ethics in this world, and does a lot of it via sci-fi and really has incredible work. But she crowdsourced this list. It's 112 universities, 200 plus courses across the world. These classes have existed. There's something we're doing wrong. Something in the way we're teaching folks, something in the way we're saying it's fine to have ethics as the one class you take, maybe your final senior year, and then now you know what to do with your technology. So this is not new. It's existed for a long time, but we really have to think of a new way to really integrate this into what we do, both how we teach students and then what happens when they go on and work for all of these companies. So really, my call to action for all the folks in the room, and this was also the same slide I used for a software engineering conference that I was at recently. Andrew knows this because he's at the Berkman Klein Center with me, but this idea of honoring all expertise across teams, discipline, and people. So for the engineers in the room, there's so much that groups like Science, Technology, Society have been doing. There's a lot of where people in law think deeply about how different services affect humans, where sociologists have been thinking about these problems for a long time, historians, anthropologists, philosophers, and bring them into the room. And industry, and you also mentioned this as well, we need to hire for disciplines with deep expertise in humans, or push academia to bring this into the curriculum as well. So we should be interviewing for these kinds of skill sets. Interviewing is actually notoriously really, really bad. We need to change it anyways. Interviewing is biased and problematic in many ways, so think differently about how we hire for these disciplines, and advocate for universities to bring this into their core competency. And finally, you've seen this in some of the big tech companies already. If you're an engineer in a big tech company, your voice is incredibly powerful. Again, it's not like it's fair or okay, but the engineering voice is usually the loudest and most powerful voice, at least in the big tech companies. So when we advocate for our companies to change, a lot of times they listen. We've seen this in the cases of, recently at least, Google with some of the contracts, and Amazon and Microsoft, et cetera. But internally, many of these companies have had engineers speaking up for a long time as well. We just don't always hear about it because things kind of work out for them internally. So if you're in any of these tech companies, use your powerful voice to bring these topics into the room, and especially if you're an engineer or developer, your voice is so incredibly powerful. So I will leave it at that, and thank you.